Question 1, part A, we need to work out 3.67 times 4.2. So we start by writing one below the other. And then we've got 2 times 7, it's 14, and we keep 1. 2 times 6 is 12, and 1, 13, and we keep 1. And then 2 times 3 is 6, and 1, it's 7. Then 4 times 7 is 28, and we keep 2. 4 times 6 is 24, and 2, 26, and we keep 2. And 3 times 4 is 12, and 2, it's 14. We can now add them up. It's 4. 3 plus 8 is 11, and we keep 1. 7 plus 6 is 13, and 1 we kept 14. We keep 1. Then 4 and 1 it's 5, and then 1. And we've got 15.414 as our final answer. In B, we need to work out 59.84 divided by 1.6. And I will start by writing this as 5,984 divided by 160, so that I'm dealing only with integers. So I have multiplied both by 100. Now, 160 into 598 goes 3 times, and 3 times 160 is 480. So if I deduct, it's 8, 1, 1, and a 4 here. Now 160 into 1,184 will go 7 times. 7 times 0 is 0. 7 times 6 is 42, we keep 4. 7 times 1 is 7, and 4 it's 11. So we deduct, we get a remainder of 64. Now I will put an extra 0 here and go into the decimals. So the decimal point appear here. 160 into 640 will go exactly 4 times, leaving a remainder of 0, and therefore the answer is 37.4. In question 2, we've got this Venn diagram with sets A and B. We have been told that the A contains the elements 6, 12, and 18. B contains the elements 2, 6, 14, 18. And the universal set is all even numbers less than 19. We start by noting that the 6 and the 18 are common to both A and B, so they will appear in the intersection. And then we've got the 12 in A, the 2 and the 14 in the only B region. And we also need to consider the remaining elements that belong to the universal set but are not part of A or B. And these are 4, 8, 10, and 16. In question 3, we are asked to work out 4 and a fifth minus 2 and 2/3, and we need to give our answer as a mixed number. So I will present 2 ways in which you can do this. The first way is by expressing everything as improper fractions. So it's 21 over 5 minus 8 over 3. Now the LCM of 5 and 3 is 15. So I will multiply the first one by 3 to get 63 over 15, and the second one by 5 to get 40 over 15, which leads to 23 over 15, which as a mixed number is 1 and 8 over 15. The alternative approach will be to start by writing 4 and a fifth minus 2 and 2/3 as 4 and 3 over 15 minus 2 and 10 over 15. Now we can write 4 and 3 over 15 as 3 and 18 over 15 minus 2, 10 over 15. And then I will do the integers with the integers and the fraction part with the fraction part. So 3 minus 2 is 1, 18 minus 10 is 8, and we get the answer of 1 and 8 over 15 as well. Question 4, the value of Tamara's house was 220,000, and for Rahim it was 160,000. Now we've got a decrease of 20% for Tamara and an increase of 30% for Rahim, and we need to work out which house had the greater value. So for Tamara, we have a decrease of 20%. So if I multiply 20% of 220,000, I can simplify out the zeros here. So 1, 2, 1, 2. So this leads to 44,000, which means that the house has decreased by 44,000. So 220,000 minus 44,000 gives me an answer of 176,000 pounds. And then for Rahim, we said we were looking at an increase of 30%. So 30 over 100 times 160,000. Once more, we will simplify out the two zeros. And this leads to 48,000. And therefore, the new value is 160,000 plus 48,000, which gives an answer of 208,000. And therefore, we can conclude that Rahim's house has the greater value. This is because 208,000 is greater than 176,000. In question 5, we've got Rosie, Matilda, and Ibrahim who collect stickers in the ratio of 4 to 7 to 15. And we've been told that Ibrahim has 24 more stickers than Matilda. We need to work out how many more stickers does Ibrahim have compared to Rosie. So if we look at the ratio here and we compare Matilda with Ibrahim, we can see that they have a difference of 8 from 7 to 15. So this is 8. And then Rosie to Ibrahim, that's 11 here. So this means that we can use a ratio. A difference of 8 corresponds to 24 tickets. So a difference of 11 will correspond to X tickets. So X is 11 times 24 over 8. I simplify the 8 with the 24, I get a 3, and this gives an answer of 33 stickers. In question 6, we are being given a prism here. It's a triangular prism, and the base of the triangle has a length of 5 centimeters. The prism has a length of 25 centimeters, and the volume is 150 cubic centimeters. We need to work out the height. I will start by calling the height here h. Now we know that the volume is the cross-sectional area times the length. So we know that the volume is 750. The cross-sectional area is simply the area of the triangle here. So it's base times height over 2, and the length is 25. So we're trying to find h. First of all, the 750 with the 25 simplifies, leaving a 30 on the left-hand side. So we've got that 30 is 5h over 2. I see another simplification. It's the 30 with the 5, leaving a 6 here. And if I cross multiply, I get that h is 12. In question 7, it's a cube with edges of length x centimeters and a sphere of radius 3 centimeters, and these two have the same surface area. We need to show that x is root of k pi for some integer k. We will start with the surface area of the cube. We know that it's 6 times this area here. It's a square. So the surface area of the cube is simply 6 times x squared. And the surface area of the sphere is 4 pi r squared. The formula is actually given for us here on the top right hand side. So it's 4 pi r squared. So we know that the radius is 3, which means this is 4 pi times 3 squared. Now 3 squared is 9, 9 times 4 is 36, so this is 36 pi. So I will equate 6x squared with 36 pi. The 6 with the 36 leaves me a 6 on the right hand side, and therefore we get that x squared is 6 pi, which means that x is the square root of 6 pi. In question 8, we need to solve x squared is 5x plus 24. This is a quadratic in x. We collect everything on the left hand side to get x squared minus 5x minus 24 is equal to 0. This factorizes into x minus 8x plus 3. So it means that either x minus 8 is 0 or x plus 3 is 0, which leads to two solutions: x is 8 or x is negative 3. In question 9, write down the value of 7 to the power of 0. Now we know that anything to the power of 0 is simply 1. Then 3 times 3 to the 6 times 3 to the minus 6. When we multiply with a common base, we add the indices. And so this will be 3 to the 1 plus 6 plus negative 6, which is 3 to the 1, which is just 3. In C, it's the value of 2 to the minus 4, which can be written as 1 over 2 to the 4, which is 1 over 16. And then for D, the value of 27 to the third is simply the third root of 27, which is equal to 3. In question 10, we've got a shape made of 6 identical squares. The total area is 5406 square centimeters, and we need to find an estimate for the length of one side of each square. So one such square is that one, and we can call each side having a length of x. So I can start by doing 5406 divided by 6 to get the area of each square. 6 into 54, it goes 9 times, so a remainder of 0. Get the 0 down. 6 into 0 goes 0 times, and then get the 6 down, which goes 1 time, and I'm left with a remainder of 0, of course. So each of these squares has an area of 901 square centimeters, which means that x squared is 901. So x is the square root of 901. Now this is really close to a square number, 900, so it's approximately the square root of 900, which is 30. So the length of one side is approximately 30 centimeters. In part B, we need to decide whether the answer we just obtained, the 30, is an underestimate or an overestimate, and we need to give a reason to explain our answer. So the answer here is quite simple. Since 900 is less than 901, which was the actual area of each square, then our answer is an underestimate. Question 11, we've got the rectangle A and rectangle B, and the two areas are the same, and we need to find an expression for y in terms of w, where the area of A is 6 times 2w plus y, and this is equal to 7w brackets 3y plus 6. I will expand to get 12w plus 6y is 21wy plus 42w, which means that 6y minus 21wy is equal to 42w minus 12w. Now on the left hand side, I can factor out the 3y, leaving me with 2 minus 7w in the brackets, and this is equal to 30w. Now the 3 with the 30 simplified to leave me with a 10 on the right hand side, and therefore we have that y is equal to 10w over 2 minus 7w. In 12, we are being given information about the heights of 40 plants, and we are told to draw a cumulative frequency graph. Now we know that we should be plotting the cumulative frequency against the class endpoints, so 4 against 5, 11 against 10, and so on. So we start by plotting the points, and then we can connect them either with straight line segments as shown to get a cumulative frequency graph, or we could draw them with a smooth curve. Both of them are acceptable by the examiner. Now we need to use the graph in part B to find an estimate for the median height of the plants. Since we've got 40 plants in total, the median is halfway through, so I'll go at 20 and then come back down, and I see that I get 13.5. So my answer for the median is 13.5. It's worth noting that anything that follows through from the cumulative frequency graph would have been acceptable for this mark here. In 13, we're told that Ted is trying to change 0.43 recurring to a fraction, and we've got the start in his method. So he started off by multiplying by 10, and then he did 10x minus x, and we need to evaluate Ted's method so far. Now for this method to work, we need to have the same decimal part here, so that upon deduction we are left with a purely integer result on the right hand side. Obviously this is not the case here, so we can say that his method is not gonna lead to 0.43 recurring being expressed as a fraction, because the decimal parts are not the same, and he would have obtained the right answer if instead of multiplying by 10 he multiplied by 100, because that would have been 43.43 recurring, and then these and these would have the same decimal part. In 14, we need to show that the area of this shape is given by the expression 2x squared plus 24x plus 46. I will start by splitting this into two rectangles. So we can see that this part here is x plus 7, because all of this was x plus 11 and this is 4. So we can say that the area is 4 times x plus 1 plus 2x plus 6 times x plus 7. Now I will expand to get 4x plus 4 plus 2x squared plus 14x plus 6x plus 42. I will collect like terms, 2x squared. Now 4x plus 14x plus 6x is 24x, and then 4 plus 42 is 46 as required. In question 15, we need to express the sum of these two fractions as a single fraction. So I start by finding the lowest common multiple of the two denominators, the 2x and the 5, which is 10x. So everything will be expressed over 10x. It's obvious that the first fraction is to be multiplied by 5 and the second fraction by 2x. And this leads to 5 brackets 4x plus 3 plus 6x. I will expand to get 20x plus 15 plus 6x over 10x, which leads to 26x plus 15 over 10x. In question 16, we've got a bag which contains 3 red counters and 5 yellow counters, and Jude takes at random 3 counters from the bag. We need to work out the probability that they take exactly 1 red counter. One way of approaching this is through a tree diagram. So we have 3 draws, and each draw may lead to a red or a yellow counter. So my tree diagram would look something like this. I could add up the probabilities. We start with a total of 8 counters, 3 of which are red and 5 of which are yellow. Now with the first, a counter drawn out is red. That means we are left with 2 red counters out of a total of 7 counters. And if this continues for a second time, then that's going to be 1 over 6. We know that the sum of the probabilities of the branches should be 1. So we have a 5 over 7 here and a 5 over 6 here. Now if we took a red and then a yellow one, it means that we'll now have a total of 2 red and 4 yellow. So it's going to be 2 out of 6 for a red and 4 out of 6 for a yellow. And we will proceed similarly on this side here. If we started off with a yellow one, it means we've got 4 out of the remaining 7 being yellow. So 3 out of 7 is red. And then if the second one was also yellow, we're now having a chance of 3 out of 6 of being yellow and 3 out of 6 of being red. But if it was a yellow then a red, we are facing exactly this scenario here. So it's going to be 2 out of 6 for red and 4 out of 6 for yellow. Notice that I do not simplify the fractions here. I prefer them unsimplified so that the denominator matches the number of counters in total in the bag. Now, the probability of getting 1 red counters could be obtained through red, yellow, 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 red, yellow, or yellow, yellow, red. These are the 3 different routes that will lead me to the required answer. So to find the probability required, I multiply the probability of the branches through which I travel. So it's going to be 3 over 8 times 5 over 7 times 4 over 6. This is the red, yellow, yellow scenario. Plus 5 over 8 times 3 over 7 times 4 over 6, which is the yellow, red, yellow scenario, plus 5 over 8 times 4 over 7 times 3 over 6, which is the yellow, yellow, red scenario. So we can see that in all three cases we've got numerators of 3, 5, and 4, and denominators of 8, 7, and 6. So this is simply 3 times 3 over 8 times 5 over 7 times 4 over 6. We are looking for simplifications as we do not have a calculator. So the 3 with the 6 leaves me a 2. The 4 with the 8 leaves me a 2. So in the numerator is 3 times 5, which is 15. And in the denominator is 2 times 7 times 2, which is 28. The final answer is 15 over 28. In 17, we are asked to show by shading the region satisfied by all three inequalities given here, and we need to label the region R. So I will start with the first one. I consider 2y plus 4 is equal to x. So we see that when x is 0, we get that 2y plus 4 is 0. So 2y is negative 4, which makes y negative 2. So we've got 1 point through which we pass. I will now put y is 0, and we get that 4 is equal to x, and this gives us a second point through which we pass. Now, the line x is 3 is simply a perpendicular line, so that's easy to draw. And now for the last one, y is 6 minus 3x. We can see that when x is 0, we get that y is 6. And when y is 0, we get that 6 minus 3x is equal to 0. So 6 is 3x, so 2 is x. Again, we've got 2 points through which we pass. We can plot these points and join them with straight lines to start considering the region satisfied by all three inequalities. So let's start with the first one. We were passing through 0, negative 2, and 4, 0. So 0, negative 2 is here, and 4, 0 is here. And therefore, the straight line should be this one here. So this is the line with equation 2y plus 4 is equal to x. Similarly, for the third line, it was passing through the point 0, 6, and the point with coordinates 2, 0. So 2, 0 is here, and again I will draw the straight line passing through both of these points. There it is. So this is the line with equation y is 6 minus 3x. And finally, the line x is 3, which is this one here. I have drawn all as dotted lines because we had strict inequalities. And I now need to consider the region satisfied by all three inequalities. We were told that 2y plus 4 is less than x, so we need to be below this line here. For the second line, x less than 3, it means we need to be on the left side of the line x is 3, so we want to be this way. And for y being less than 6 minus 3x, we want to be below the line, so we want to be here. We are looking for the region where everything is satisfied, and it's obviously the region here, and we need to shade this and label it with the letter R. So this is the final answer. This is the region here, which is satisfied by all three inequalities. In 18, we're given a trapezium ABCD. We are told that the area is 66 square centimeters, and we need to find the length of AB, given that additionally AB to CD is 2 to 3. So I will start by saying if AB is 2x, then DC is 3x. We know that the formula for the area of a trapezium involves the perpendicular height, so this distance here is the height h, so I will start by finding h. I will say that sine of 30 is h over 6. We know that sine of 30 is a half, so a half is h over 6. I cross multiply 6 over 2 is equal to h, so the height is 3. So we can now say that the area of the trapezium is base 1 plus base 2 over 2 times the height, which we just found to be 3 centimeters. So 66 is 5x over 2 times 3. I will start by simplifying the 3 with the 66. They leave me 22 on the left-hand side. And then I can cross multiply to get 22 times 2 is 5x. So 44 is 5x. So 44 over 5 is equal to x. Now 5 into 44, it goes 8 times, and the remainder of 4 over 5. So 8.8 is the value of x. We were asked to find the length of AB. So AB is simply 2x, which is 2 times 8.8, which gives an answer of 17.6 centimeters. It is worth noting here that if you ended up with non-decimals as your final answer, so if you gave your answer as an improper fraction, then you would have been penalized with a mark. 19, we need to show that 8 plus root 12 over 5 plus root 3 can be written in this form here. So we're pretty much asked to rationalize the denominator. We know that in this case we need to multiply intelligently by 1 in order to get rid of the root in the denominator. So I multiply by 5 minus root 3 over 5 minus root 3. If I expand the numerators, I get 8 times 5 is 40 minus 8 root 3 plus 5 root 12 minus root 3 root 12, and all of it over 25 minus 5 root 3 plus 5 root 3 minus root 3 times root 3, which is 3. Now in the denominator, the minus 5 root 3 with the 5 root 3 go away. So I'm left with a 22 in the denominator, and then in the numerator we've got 40 minus 8 root 3 plus 5 root 4 root 3. And then root 3 times root 12 is root 36, which is just 6. So this further simplifies into 34 minus 8 root 3 plus 5 times 2 is 10 root 3, and all of it over 22. So this is 34 plus 2 root 3 over 22. I haven't finished. I will take a factor of 2 in the numerator. So it's 2 bracket 17 plus root 3 over 22, which means that the 2 with the 22 simplified to leave me with an 11 in the denominator. So the final answer is 17 plus root 3 over 11. In 20, we're being given the graph of x squared plus y squared is 30.25, and we are asked to use the graph to find the estimates to the solutions of these simultaneous equations. So in other words, I need to draw the line y minus 2x is 1 on my diagram and find the points of intersection. So if y minus 2x is equal to 1, then I could say that when x is 0, we get that y is 1, and I could put another point. I could put x is 3, leading to y minus 2 times 3 is equal to 1. So y minus 6 is 1, which means that y is 7. So we know that we pass through 0, 1. So here's the point 0, 1, and the point 3, 7. And I will draw the line passing through these 2 points and identify the points of intersection with the already drawn graph. We see that the points we're looking for are this one here and this one here. So this here has coordinates 2.1, 5.1 or 5.2, depending on where you see the point of intersection. So I would say 2.1, 5.1. And the other one here, it's at minus 2.9 or 2.8. So minus 2.8, we could say, comma, minus 4.7. So these are the 2 points of intersection. So as my final answer, I would say x is 2.1, comma, y is 5.1, or x is minus 2.8, y is minus 4.7. In 21, it's a question on functions f and g. We need to work out g of f of 1, and I will actually start by finding f of 1, which is 3 times 1 squared plus 1, which is 3 plus 1. So that's 4. And then g of f of 1 is g of 4, which is 4 over 4 squared, which is 4 over 16, which simplifies to a quarter. Now in B, we are told that the function h is the inverse of the composite function f of g, and we need to find this function h. I will start by finding f of g of x, which is f of g of x is 4 over x squared. So this is 3 times 4 over x squared all squared plus 1. So it's 3 times 16 over x to the power of 4 plus 1, which leads to 48 over x to the power of 4 plus 1. I will let this be my y, and then I will interchange x and y and try to make y the subject. So x is 48 over y to the power of 4 plus 1. So x minus 1 is 48 over y to the power of 4. So x minus 1, y to the power of 4 is 48, which leads to y to the power of 4 is 48 over x minus 1, and therefore y is the fourth root of 48 over x minus 1. My final answer would be that h of x is 48 over x minus 1, the fourth root of this. In 22, we need to find the coordinates of the turning point on this quadratic curve. There are two ways we can do this. One way is to use differentiation. So we say dy dx is equal to 18 minus 6x. We know that at the turning point the derivative is 0. So 18 is equal to 6x, leading to 3 is x. And when x is 3, I will substitute to get the y value. So y is 9 plus 18 times 3 minus 3 times 3 squared. Now 18 times 3 is 54. 3 times 3 squared is 3 times 9, which is 27. So this is 9 plus 27, which is 36, and therefore the point is 3,36. Alternatively, we could have used completing the square. So I could have said that y is 9 minus 3 times x squared minus 6x. So this is 9 minus 3 times x minus 3 squared minus 3 squared, which leads to 9 minus 3 brackets x minus 3 squared minus 9. And therefore it's 9 minus 3 brackets x minus 3 squared plus 27. I multiplied the negative 3 with the negative 9. So this leads to 36 minus 3 times x minus 3 squared. Now since y is 36 minus something which is square, so it can never go negative, it means that the turning point in this particular case, a maximum, will be when x is 3, in which case y will be 36. So we still get that the point will have coordinates 3, 36. This is the turning point on the given quadratic curve.